Hello. Hi everyone, and welcome to this live stream where we'll be discussing the solutions for weekly contest 119. First of all, please let me know that if I'm properly audible, and sorry for being late. Hello, am I properly audible? Okay. So let us start. Let us start with the first question, that is high frequency, and then we'll go to further problems. I'll just present my screen. So I hope the screen is visible. Please let me know. Okay, so let us start with the first question, that is high frequency. So what does question say? It says that you are given a string s of lowercase Latin letters with size n. So there are n characters, right? Your task is to find lexicographically smallest substring with the maximum frequency. So basically here we are told that we need to find the lexicographically smallest substring, right? Smallest, and it should also have the highest frequency. So basically among all the substrings which have highest frequency, what we need to do, we need to return the one which is lexicographically smallest. Among all the substrings which has the highest frequency, we need to return the lexicographically smallest, right? Now when can we say one string is lexicographically smaller than another? Two cases. First, if all the characters are matching and if one is a prefix of another. So for example, I have string abc and another is abcd, then I can say abc is lexicographically smaller than abcd, right? Another is when the first matching character, if we compare both the strings from starting to end, and if the first character which does not match in both the string, this character it is smaller in whichever string will be lexicographically smaller. So for example, a b c d e and a b c a f g. Now here if I look here, this is the first not matching character if we start looking from start to end, and it is smaller in the second string. So this will be lexicographically smaller than the first one, right? Now we are told that we need to find the lexicographically smallest string, or which also has the highest frequency. So among all the highest frequency possible substring, we need to find the lexicographically smallest, right? Now understand one thing. If we talk about lexicographically smallest and with highest frequency, then whatever, like suppose we get ab as the highest frequency, suppose ab, this is my string. So ab has the highest frequency, that is 5, ab substring. But can I say a is also a substring of the whole, a is also a substring which is present in this, and it is also present 5 times, right? Can I say b is also a substring which is present in this and it is also present 5 times? Why? Because a is smaller than a is a substring which is present 5 times, b is also a substring which is present 5 times, ab is also a substring which is present 5 times. But A is lexicographically smaller than AB and B is greater than AB, right? So A is the lexicographically smallest substring with the highest frequency. So whatever you get the answer as, suppose, let us suppose that you get an answer, the highest frequency substring as 3 length, okay, whatever it may be, suppose X, Y and Z. But if X, Y and Z is repeated maximum number of times, suppose it has frequency f, then the first character of this string, which is X, is also a substring of the given string. And if XYZ has the highest frequency f, X will also be present at least f times, and X is lexicographically smaller than XYZ. So what does it mean? That our answer will be only one character, because that will be lexicographically smallest substring, and we need the lexicographically smallest substring with the highest frequency. So what would be our answer? Our answer is of one character only, that we saw from this example, and it should also have the highest frequency. So basically, from all the characters from small a to small z, the character which has the maximum frequency will be my answer. Is this the concept clear? Is the concept clear? So basically, we need to return the character which has maximum frequency, because it has maximum frequency and it will also be the lexicographically smallest substring with maximum frequency. Now here we have AB also as maximum frequency 5, but the first character of this A, if you consider alone, that is also a substring with maximum frequency, and that is lexicographically smaller than AB. So basically we need to return the character which has maximum frequency, right? So now let us code it. So let us take a string answer is equals to null. Let us take one counter of size 26. Let us take one maximum frequency index initialized with -1, and let us take one integer I. Now for I equals to 0 to n, we will go from I plus plus, and if so, first of all, I'll increment the count. So count of S of I minus 97 plus plus, because that is the ith character. Like I'll do minus 97 because we are converting when S of I is a character. When we will use it at index, it will represent its ASCII value, right? So frequency 4 for AB. Okay, so someone has doubt in this example, I think. So here AB is there 5 times, no? AB, 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 and AB, right? Okay. So now let us. So now I have calculated the frequency of all the characters. Now for I equals to 0, I is less than 26, I plus plus. If count of I is greater than 0, only then we will consider it. So if max frequency equals to -1, or count of I is greater than count of max frequency, because max f will represent the index which has the maximum count, okay, then max f will be equals to I, right? And our answer will be, answer is equals to answer plus character of max frequency plus 97. We will again convert it back into the character format, okay. Okay, so so okay, so we have not initialized this, so let us initialize it. For I equals to 0, I is less than 26, I plus plus, counting of I equals to 0 initially. Right, we got G. Let us submit it. So we have solved this problem successfully. Any doubt in this? Please let me know. Any doubt? All is clear. Okay. Okay, so now let's move on to the second question. Plucking flowers. Okay. Okay. So what does this question say? As Women's Day is coming, Geek decided to give one flower to each woman he knows. Geek knows K women's. Geek's neighbor has a garden in which there are n flowers and each flower has a beauty associated with it. That is, each flower has a beauty bi. Geek wants to pluck exactly k flowers from his neighbor's garden such that the sum of the beauty of all the flowers he plucked is maximum. Okay, so let us first understand this much. So now on Women's Day, Geek wants to gift one flower to each of the women he knows. Okay, he knows k women, so he need k flowers. Now there is a garden in which there are n flowers total. Okay, and out of this Geek will pluck exactly k number of flowers because he knows k women's, right? And he wants to pluck k flowers such that also each flower has a beauty associated with it, and the beauty value associated with it is given with the help of an array b. Geek wants to pluck this k flowers such that the sum of beauties is maximum, right? Okay, now let us read further. Geek wants to pluck exactly k flowers from his neighbor's garden such that the sum of the beauties of all flowers he plucked is maximum. But to not get caught, he can't pluck more than one flower in a row. More formally, he can't pluck two flowers if they are adjacent to each other. Okay, our task is to find what can be the maximum sum of beauty of all flowers Geek can get, right? So, what they have said is he will not pluck any two consecutive flowers. Okay, to be on the safe side. Okay, so two consecutive flowers cannot be plucked. So if we look at the examples, then suppose we have three flowers in the garden and we need to pluck two flowers, then there is only one option, that pluck the first flower and the last flower. First plus last will give us two. Okay, right? So we cannot pluck the central flower. Why? Because we need to pluck exactly two flowers and we cannot pluck two consecutive flowers, so we need to pluck in this way only. If we look at the second example, if we have n equals to 4 and k equals to 2, then I can take uh, first and third flower or second and fourth flower. In both the ways you will get the sum of the beauty as 5, right? And k is always less than equal to ceiling n by 2. So what does they try to say is that we will always be able to pluck k flowers. Okay, the value of n is such that even after considering the rule that no two consecutive flowers will be plucked, even then we can pluck k flowers. Okay, the their value of n is such that. Okay, now how can we solve it? One of the ways to solve it is by checking all the possibilities, right? Check all the possibilities. So what are the different possibilities? So suppose let's say I call a recursion function because I need to check all the possibilities. So I call a recursion function passing n and k, which will basically return me the maximum beauty if I take k flowers and if I consider all the n flowers, right? Now, if I consider all the n flowers, Now what will I do? From the last flower to the first flower, for each flower I'll have two choices whether to take it or not to take it, right? So here I have two choices. Suppose I decide to take the last flower, then it the remaining number of flowers would be n minus 1, and the remaining number of flowers which I need to take will also be n minus 1 plus b of n. Suppose I am taking one index, then plus b of n, because I am considering this flower. And if I do not consider this flower, then the remaining would be n minus 1 and k. What does this denote? Maximum sum of beauty using k flowers, if I consider n flowers, is equals to maximum beauty which I can get if I want k minus 1 flowers considering n minus 1 flowers, plus beauty of the last flower, or like it would be max of both of these. Okay, max of this case or this case, maximum beauty which I can get from k flowers considering the first n minus 1 flowers. Okay, now again at this point I will have two choices, like consider the first n minus 2. No, at this point I will not have two choices, because I have considered the nth flower, I cannot consider the n minus 1th flower, so I cannot pick it. So here I will have only one choice. Like during recursion we can take one area of something which can basically mark whether to take a flower or not to take a flower. So basically here I will not be able to take it, so the remaining number of flowers will be n minus 2, and the flowers to be taken is k minus 1 plus b of n. Okay, because b of n is the flower which you have considered. Here I will have two choices, either to consider it or not to consider it. If I consider it, the number of remaining flowers will become n minus 2, and the remaining flowers which I need to pluck will become k minus 1. And since I have taken n minus 1 flower, so its beauty will be added. So the recursion value passed by this function plus this value. And if I do not consider it, again it would become n minus 2 and k. Okay, so in this way the recursion will be formed, and the time complexity for this would be I can say nck, because whenever k will become 0 we will stop. So out of n flowers I need to consider k flowers, but it would be slightly less than this. Why? Because we are not considering consecutive flowers. So here for example we will not go, okay, because I have taken nth flower, will not take n minus 1th flower. But still this will be an upper bound, and recursion will take a lot of time, and it will give us time limit exceeded, right? The value of n is itself 1000, so we need to think of something efficient. Now here we have n and k, right? Understand one thing, we need to convert this into polynomial. So can we think of converting this recursion into a dynamic programming problem? We need to have two cases. First is there should be overlapping sub problems. What does overlapping sub problem property say? It says that whether the same sub problem is called again and again in the recursion tree. Yes, this sub problem which says to pick up k minus 1 flowers considering the first n minus 2 flowers, and here also we have the same called recursion function n minus 2 and k minus 1. So the same sub problems are repeated, so there is overlapping sub problem property. We should have also have optimal substructure property. What does optimal substructure property say? It says that the solution to the sub problems, the optimal solutions to the sub problems are used to count the optimal solutions to the bigger problems. Here are we doing that? Yes. The answer to this sub problem is max of this and this. The answer to this sub problem would be max of this and this. So we have overlapping sub problems and optimal substructure property, so we can convert this into a dynamic programming problem. So suppose we think of tabulation method and try to fill up a table, right? So first of all we need to think about what will be the state condition of the table, like what will we store in it. So the if we look at the recursion function, we have passed two parameters n and k, that is the number of flowers to be plugged remaining and the total number of flowers to be considered which are remaining, right? So I can take a dp table of n plus 1 and k plus 1 size, where dp of ij will denote number of maximum beauty of maximum sum beauty which we can achieve if we are plucking j flowers from the first I flowers, considering the rule in mind that we cannot pluck two flowers together, two consecutive flowers. Okay, so dp of ij will denote that. So first of all, what we do, we fill in the base cases and then we fill the whole table using for loops, right? So what would be the base cases? So let's write the code and I'll explain it in that only. So here I'll take long dp of n plus 1 and k plus 1, right? Let me take some variables to loop over. Okay, now first of all, fill in the base cases. Suppose you have zero number of flowers and you want to pluck k number of flowers or I number of flowers, it is not possible. So dp of 0 I will always be 0. So for example, for I equals to 0, I is less than equals to k I plus plus. dp of 0 I will be equals to 0, because if I want to pluck I number of flowers but I have zero number of flowers, then the sum of beauty will be 0, right? Can you repeat how to create table? Okay, okay, so let me explain the table here only. Okay, so now see, if we look at the recursion, I hope you have understood the recursion, right? So in recursion we are passing two parameters n and k, that is the flowers which we need to pluck, like the remaining number of flowers to be plucked and the remaining the flowers which we are considering. So nk will basically denote we need to pluck k number of flowers from the first n flowers. N minus 1 k will denote we need to pluck k flowers using the first n minus 1 flowers. Okay, but this will give us time limit exceeded, right? Now we need to convert this into dynamic programming. Okay, the overlapping sub problems and optimal substructure property is there, right? So now what we can do is, here we can say that here in recursion we are passing two values n and k, right? So basically in a state of dynamic programming we will need these two things. And what can be the maximum different number of steps? Like for all the possibilities of n, we are taking all the possible values of k. So dp of n plus 1 into k plus 1 can be the table which we can take. Like dp of ij will basically denote the maximum beauty which we need when we which we get when we plug the j number of flowers using the first I number of flowers. So this is how we get this table. Now we need to fill this table and finally we will return dp of n and k, which will denote the maximum beauty which we can get if we want to pluck k number of flowers using the first n number of flowers. Okay, so we will return it. So now we need to fill this. So whenever we fill a table, first of all we fill the base cases and then we use the for loop to fill the complete table, like we relate the larger problem with the smaller sub problem. Okay, so first of all I have taken for I equals to 0 to k dp of 0 I equals to 0. Why? Because if you have zero number of flowers you cannot pluck any of them, so the maximum beauty would be 0. Now for I equals to 0, I is less than equals to n, I plus plus, dp of I 0 will also be equals to 0. Why? Because here we are saying for I equals to 0, I is less than equal to n, I plus plus, dp of I equals to 0, dp of I 0 equals to 0. Why? Because no matter how many number of flowers we have, suppose we have I number of flowers but we need to pluck 0 number of flowers, then the maximum sum beauty which will obtain will be 0, because we do not need to pluck any flowers, right? Also one more thing which we need to fill is that if we have only one flower, right? Or let us now fill the table. So for I, or one more base case would be if we have only, like if we need to pluck only one flower, it would be the maximum beauty flower considered till now. So basically dp of 1 comma 1 would be b of 0, because if we need to pluck one flower and there is only one flower, then that only that would be plucked. and for I equals to 2, I is less than equals to n I plus plus dp of I1, that is if we need to pluck one flower considering the first I flowers, would be max of dp of I minus 1 1 or b of I minus 1. That is the maximum beauty which we can get if we want to pluck one flower considering the first I flowers is the maximum beauty which we can get by plucking one flower considering the first I minus 1 flowers, right? Suppose we do not pluck the ith flower, or we considered to choose the ith flower. What is the beauty value of ith flower? It is b of I minus 1. Here I have taken in the loop I from one index, but in vector it would be 0 index. So ith flower will be at index I minus 1. So I have taken b of I minus 1. Is this much clear? Now we will fill the remaining. So for I equals to 1, I is less than equals to n I plus plus. For j equals to 2, because for j equals to 1 we have filled in, j is less than equal to k, j plus plus. If 2 star j is less than equal to I plus 1. Why? Because if I want j number of flowers, then the value of I, that is the number of flowers which I am considering, should be at least 2 star j minus 1, right? Because suppose I want to take j equals to 3 number of flowers, then the value of I should be at least 5, that is 2 star j minus 1. Then I'll plug 0th flower, second flower and the fourth flower, right? So it should be at least that much because we cannot plug two consecutive flowers. So if 2 star j is less than equal to I minus 1, else if that is not possible, then dp of ij would be 0, because if we cannot pluck j number of flowers, if we do not have enough flowers, keeping the rule in mind, then we cannot obtain the beauty, so maximum beauty would be 0. Else, now there are two choices: either we consider the ith flower or we do not consider the ith flower. So dp of ij is equals to max of, suppose I consider the ith flower, so its beauty would be b of I minus 1, plus I also need to consider the remaining j minus 1 flowers. But since I have taken the ith flower, I cannot take I minus 1th flower because that would be consecutive. So b of I minus 1 plus dp of I minus 2 and j minus 1. So I am considering the ith flower. So the remaining would be j minus 1 flowers. So it would be dp of I minus 2 and j minus 1. So maximum beauty which we can get by plucking j minus 1 flowers from the first I minus 2 flowers plus the beauty of the ith flower. So totally we have plucked j number of flowers. And if we do not consider the jth flower, then it would be dp of I minus 1 and j, because if we do not consider it, we still need j number of flowers considering the first I minus 1 flowers, and then we can return it. So we can return dp of nk, which will denote the maximum beauty which we can get by plucking k flowers considering the first n flowers. Okay, so b of I is integer type, so that's why we are getting problem. So let us take one, we have taken one variable m, so m is equals to b of I minus 1, and I'll replace b of I minus 1 with m. Because b is of type integer and dp is of type long, so they are not comparing those two values. Uh, 42 and 21. So we have solved this. Let us submit it. So we have solved this problem successfully. Have you got this case? Have you understood the solution? Please let me know if you have any doubts in this. Memoize please. Okay, so let us try to solve it by memoization. So first of all, what we can say is, so we'll remove all this, right? And we will call, let us call the function fill, pass in the dp function. Here the value of k cannot go more than 500, right? So let me take this as 501. Actually n is 1000, so okay, so let us take 501. Fill this table, and considering the first n elements, and we want to fill the k number of elements, right? And we also need to pass the vector, right? And finally we will return what? Dp of n k. Okay. Sorry. So void fill uh, long dp of this much size, then I need n, I need k, and I need vector which is b. Okay. Now let us first of all write the base cases. So if n is equals to 0, that is there are no elements, then dp of uh, n and k would be equals to what? 0, right? And will return if k equals to 0, that is if no elements are to be considered, then also dp of n and k would be equals to 0 and will return, right? Now what can be the other cases? Also if 2 star k is less than or equals to is plus 1 should be less than equal to n, only then this will work. So if it is greater than n, then dp of n and k will be equals to 0, right? Also let us initialize this table with -1, so we will know which tables are filled and which are not. Okay. So dp of ij equals to -1. Okay. So we have considered these cases. Now we could have put all of them in one if case only, but that's okay, right? What can be the other things? If the number of flowers to be plucked, so now so we will put this condition after one condition, because if we have only one flower to be plucked, right? If k is equals to 1, if we have only one flower to be plucked, then that condition would be filled first, because if n is equals to 1 and k is equals to 1, still that is a valid choice, because we can pluck one flower, right? So now what will we get here? If k is equals to 1, then dp of n k would be equals to um, also we will, so if dp of nk, so either we consider that element, then it would be b of n minus 1, and if we do not consider that element, then it would be dp of n minus 1 and 1, right? So if dp of n minus 1 and 1 is equals to minus 1, then we need to call the recursive function, else I can say dp of n and k is equals to max of dp of n minus 1 and 1, that is we considered that element, right? And else it would be, sorry, we did not consider that element, else it would be b of n minus 1, that is we considered that element. Is this much clear? Someone is asking mathematically, okay, why 501 and not k plus 1? Because whenever we pass a 2D array in C++ to a function, we need to denote the size of the uh, second the number of columns, right? That's why I've taken 501. Okay, so now till here we have calculated, and here what would be the case? dp of n minus 1 and k would be equal to max of b of n minus 1, or suppose we do not consider this, then I need to call the function fill, passing in the dp table, and I want to calculate n minus 1 and 1, right? Because that's the value of k, and I also need to pass the b, right? So these are, this much base cases are clear, right? So we have completed this much. Now if the last part would be what, and here we will say return. So if k equals to 0 or n equals to 0, it would this would handle this. If k is 1, then this would handle it. If 2 star k plus 1 is greater than n, so we cannot plug k number of flowers using the first n flowers, then we will make it 0. Now the last case would be dp of nk, right? So if I write in the comments, so dp of nk is equals to max of dp of n minus 1k comma b of I minus 1 plus dp of n minus 1 and k minus 1, right? So now I need to check whether I have called the whether dp of n minus 1 and k minus 1 is filled or not. So if dp of n minus 1 k equals to minus 1, then first of all fill that. So fill uh, dp, then sorry, these are capitals, so I'll take them as capital. So fill dp n minus 1 k, and I'll pass b. Okay, if dp of n minus 1 and k minus 1, this is also not filled, then I'll call the function fill dp of n minus 1 k and b. So now both of these are filled, so now I can say, I can copy paste this, right? And I need to make these capital letters, right? So all the cases are covered. So if n equals to 0, it would be 0. If k equals to 0, it would be 0. If the number of flowers to be plugged is 1, then we will check whether n minus 1, 1 is minus 1. Then we will call the fill function, else we can directly use that. We will not fill it again. And if the number of flowers to be plugged is not possible, then we will return, make it 0 and return. And this is the last equation, right? And then we'll return from here. Okay, so now let us compile it. Okay, n was not declared. Okay, so b of n minus 1 I have taken, right? So this would be b of capital N minus 1, but this might also give error because b array is int and the other part is invalid use of void expression, line 3059. Okay, sorry. So fill dp n minus 1 1 and b, and then I can say I can remove this, right? So if it is minus 1, then first of all fill it and then use it, right? 91 1, sorry. Mm, so here I need to take something else. So let me take, or I can typecast it simply, right? Long m, which will be equal to b of I minus 1. So I can replace it with m, and here also I can replace it with m. I was not declared. Okay, n minus 1. 74 1 expected at the end of input in member function int. So what's uh, are we having one less closing bracket? This is if, this is if, this is if, and this is for loop, this is for loop. I think we have the a function definition is not allowed here before this token 58 8. So what is this error in line 89 1? So is any bracket open which we have not closed? Uh, okay, so here is an extra if opening bracket, right? Okay, so we have got 0, so we are doing some mistake, so we need to find it out. Mm, what's if k equals to 1, if dp of n minus 1 1 equals to minus 1, then fill it. Otherwise, take the maximum value from okay, here this should be k minus 1 because we are checking for n minus 1 k minus 1. Now let us check. Okay, so where are we doing the mistake? Hmm, let us print the values. So for I equals to 1, I is less than equals to n, I plus plus. For j equals to 1, j is less than equal to k, j plus plus. Cout dp of I and j. So the conditions are same only which we also did in the tabulation method, right? Here we are only, so oh, it's minus 1 only. So we passed in the fill function we passed the value of n and k, and so first of all it will go into if 2 star k plus 1, that is 4. Just a minute. 2 star k plus 1, that is 2 plus 1, that would give me what? 4, right? K is 2, so 2 into 2 4 plus 1 5. Okay, this should be minus 1, right? 1 minus 1, and so this is considering only the first element we can get. So I think we are missing out on something. We have called the function n comma k. This is also dp max of n minus 2 and k minus 1. Okay, so here this should be n minus 2. Okay, right. But this is what here we are getting. Okay, okay, got it. So now this will give us 2, and let us submit it. So we have solved this problem successfully using memoization also. Thank you, Khush. So yes, there was dp of n minus 2 and k minus 1. Yes, we have considered the pick and not pick method, and we solved it using tabulation as well as using memoization. So first of all, we called on nk, and these are the base cases. So if n equals to 0, so basically dp of nk will represent the maximum beauty which we can get if we want to pluck k number of flowers, considering the first n number of flowers. Now if the number of flowers which we can consider is 0, that is if n is 0, then dp of n comma k will be 0, because there are no flowers to pluck from. If k equals to 0, that is we do not need to pluck any flowers, then no matter how many flowers we have, it will again be 0, the sum of beauty. Now if we want to pluck only one flower, why I have taken this case separately, because here we are asked to choose all, we cannot take two consecutive flowers, right? So we are checking this condition. If 2k minus 1 is greater than n, then we cannot pick the flowers in such a way that we will not pick two consecutive flowers, right? So in that case dp of nk will become 0. So before this I considered this case, because if we want to pluck one flower, and if there is only one flower, then also we can pluck it, right? So for k equals to 1, we have considered it before, right? And if k equals to 1, then either we pick one flower from the n minus 1 flowers before the nth flower. So if that is not filled before, then we will call the fill function to fill that. N will become n minus 1 and k will remain 1. And then dp of n1 is maximum of dp of n minus 1 1, or m is the current index flower value. And if we cannot plug the k flowers from n flowers, keeping the rule in mind, we will make it 0. And then the final case, that is dp of nk equals to max of dp of n minus 1k if we do not consider the nth flower, and m plus dp of n minus 2 k minus 1 if we consider the kth flower. But before that I need to check whether dp of n minus 1k and dp of n minus 2 k minus 1 are filled or not. So I have checked it, and if they are not filled, I have called them. So this is using memoization. And this has also passed. So any doubt in this? Any doubt in this? Please let me know, otherwise we'll move on to the next question. Long test case are not passing, so you might be doing it with recursion. Like you need to check whether the smaller problem is calculated first. If you have already picked it, then like you do not need to, like dp of n minus 1 k and dp of n minus 1 k minus 1, if they are not minus 1, it means that that is already filled, that sub problem is already calculated, then you can directly use it. Otherwise you can call the fill function, so you need to fill that only once, right? And that's why we have initialized all of them as minus 1. So just to check that if state is filled before or not. Okay, so now let's move on to the third problem, thrindrome. So what does this question say? It says that a thrindrome is a palindromic sequence of length 3, right? So it is a palindromic sequence. We know what is a palindrome, the sequence which reads the same starting from one for start to end and from end to start, right? And if it is of 3 sequence only, then first and last element should match. Second element can be anything. A tree has total nodes 0 to n minus 1. The structure of the tree is given by array P of size n, where P of I is the direct ancestor of ith node and P of 0 is equals to minus 1, as 0 is the root of the tree. So how are we given the data of the tree? Using an array P, right? So we have a tree which contains n nodes numbered from 0 to n minus 1. Okay. And we are given an array P where P of I represents the direct ancestor. Okay. So the node which is just above I, the direct ancestor of ith node. So P of 0, it is said that is minus 1 because 0 is the root node and this is a tree. Okay. So if we have the information about each and every node's parent, then we can construct the whole tree, right? Also, you are given a string C of size n, where C of I represents the character written on the ith node. Okay, so we are also given a string C, where C of I represents the character at the ith node. Okay, now let's read further. Find the number of triplets nodes A, B, C such that A is not equal to B is not equal to C. So all three are different, right? Such that the node B comes in the simple path from A to C and CA, CB and CC forms a thrindrome. So basically what it says is we need to count all such triplets A, B, and C such that A is not equal to B is not equal to C. CA, CB, and CC forms a thrindrome, that is a three size palindrome. So basically, CA and CB should be same, and CB should be on the simple path from A to C. So in the tree, suppose this is my node A and this is my node C. Okay, this is my node A and this is my node C. Then this can be node B, this can be node B, this can be node B, this can be node B. Right? Why? Because uh, like this B comes on the simple path from A to C. Okay, and the character at the node number A and node number C should be same, then only it will form a thrindrome. So how many such triplets would be possible, that we need to tell. Okay, and we are given an example here, we'll go through the example also. And here the value of n goes up till 10 ki power 5. Okay, so we need to think of something quite efficient, like maybe in one DFS if we can solve it or something like that. Okay, so now let us see, look at this example. So the value of n is 5 and p is minus 1 0 0 1 1. The value of n is 5. The value of parent array is minus 1 0 0 1 and 1. Okay, What is the string C? String C is ACCAA and the output is 8. Okay. So the string C is ACCAA. What does this basically mean? Is that, see, zeroth node is the root node. So I have -1. This P array represents the parent. Now this is 0 index, this is 1 index, this is second index, this is third index, and this is the fourth index. So one has, at one index we have 0, it means for 1 0 is the parent. At 2 index also we have 0, so 0 is the parent for 2 also. For 3 index we have 1, it means that 1 is the parent for 3. For fourth index also we have 1, so 1 is also the parent of 4. Okay. And C is ACCAA. So here I have A, here at I have C, at second index I have C, at third index I have at the node number 3 I have A, and at the fourth number node I have A. Okay. Now if we need to find the triplets such that, like we need to find triplets A, B and C such that CA, CB and CC forms a palindrome of size 3 and B is on a simple path from A to C. So one of the ways is like 0, 1 and 3. 0, 1 and 3, because at 0th node we have A, at third node we have A, and 1 comes in simple path from A 0 to 3, right? And this forms a palindrome. So another by default would be 3, 1, 0, right? Here the triplet would be 3, 1, 0, this would be 0, 1, 3. So we need to consider both of them, right? Another would be 0, 1 and 4, because from 0, 1 and 4, 1 is in between 0 and 4. 1 is on the simple path from 0 and 4, and 0th node and 4th node have the same character. So by default another would be 4, 1, 0. Then the third would be 3, 1, 4. 3, 1, 4, because third node and fourth node have the same character A, and 1 is on the path from 3 to 4. And uh, third node and fourth node have the character A, so it forms a palindrome. And by default 413 will also be added, and the last one would be 102, because 0 is on the simple path from 1 to 2, and first node and second node have same character C, so it will form a palindrome. And by default 0, 2, 0 and 1 will also be added, so the total answer for this test case is 8. Is this much clear? Now we need to think, how can we calculate this efficiently, right? So suppose each node I consider it as the center node. Okay. So suppose I am considering, so I need the triplet A, B and C, right? So suppose I have a tree, right? Okay. I have this tree, suppose. So suppose if I consider this as the center node B in the triplet A, B and C, right? So now what character I have here is of no importance, because characters in node number A and node number C should match, right? So what I can do is, so how many possible values of selecting A and C? See, suppose in the child subtree of this tree I have let's say 3 number of A's, and in the remaining part, like this is the subtree of this node, and in the remaining part I have 4 number of A's, or let's say 3 number of A's. Then any of this node A can be connected with any of the node here. Suppose this is A and this is also A, so this will definitely come on the path from this A to this A, right? So if this node is considered as the center node, okay, and in its subtree if I have 3 number of A's, and in the remaining tree if I have 3 number of A's, then considering this node as the center node, and considering first character and the last character as A, how many palindromes I can get? 3 into 3, that is 9. So that's the first thing. Second thing is, so if I consider that element as the center node, like the I need a triplet ABC. So if I consider that as B, so one case is one character is in its subtree and another character is in the remaining part of the tree. That is one. What is another case? Another case is when both these A will be in its subtree. So suppose one A is here and another A is here, right? So they should be in the same subtree but on different parts. Okay, so if I have A here and A here, then these three will not form a palindrome, right? So both the A's are in its subtree, but one of them is in suppose this subtree and another is in suppose this subtree. Then from year to year, when I'll come from year to year, this will be a center node and it will also form a palindrome. So what I can do is one by one I can consider all nodes as the center nodes B, and when I consider them as B, I have two choices to find nodes A and C. One is that both the nodes A and C, like both of them should have the same character, right? That's the first thing. First thing is both of them are present in its subtree but on different branches, then only it will come in the center node. So for example, if there is A here, this is A here, I am considering it as the center node, then these three will not form a palindrome. But if I have one A on this subtree, on this branch, and I have one A on this branch, then this will be the on the path from this A to this A, right? So for all nodes B, I'll consider them as center node, and there will be two choices from for A and C. One is both of them are in its subtree, and another choice is that one of them is in its subtree and other is in the remaining part of the tree. So if I consider all the nodes one after the another as the center node B in the triplet ABC, and if I consider these two cases for all the, and now the nodes A and C should have the same characters, right? So when I am searching in the same subtree, I will check for A, for B, for C up till Z. And when I'll check for this condition that one of the nodes in its subtree and another is in the remaining part of the tree, in this also I'll check for all the characters from A to Z. Okay, so if we look at this example, right, if we look at our example, so this is 0, this is 1, this is 2, this is 3, and this is 4, right? This has A, this has C, this has C, this has C, this has sorry, this has A, and this has A. What would be my answer? Suppose I consider this as the center node B. Okay, in the triplet A, B, and C, I consider this as the center node. Then in its child node, can I have two same characters but on different branches? Yes. Here I have, like no, here I do not have any option. Like here there are two A's, but they are on the same branch, right? So this can't be a middle element on a simple path from this A to this A. So that case is gone. Can I have one element in, so now in this subtree I have C, and in the another subtree in the another branch also I have C. So these two can form. So that would be, I have one pair, but 102 and 201, both of them would be counted, so that is 2. Plus, if I consider this as the center node, that is B in the triplet, then one A is in this branch and another A is in this branch. So that will add answer 2 to my answer, because 314 and 413 is my answer. Then 1A, this is in its subtree and this is in the remaining part of the tree. So in the simple path from this to this also C will come. So that will also add 2 to my answer. And this A and this A, here this is in its subtree and this is not in its subtree, so this will also form one uh, path where it will form a palindrome, and this is the middle element, so that will be plus 2. Now, can I consider this as the middle element in the triplet ABC? No. Can I consider this? No. Can I consider this? No. So my answer would be 4. So what we will do, one by one, we will consider all the element as the middle element, and we will have two cases when that's a middle element, that the two remaining nodes in the palindrome ABC, A and C, both are in its subtree but on different branches. And the second case is one of them is in its subtree and the other is in the remaining part of the tree. Okay, so now let's code it. So let me take long answer. Let me take it as 0. I'll take some variables I, j. I need to form an adjacency list. So I'll form it first. So how will I form it? From the ith node, from the pith node, I can go to the ith node because pi is the parent of I. So for I equals to 1, I is less than equals to, sorry, I is less than n, I plus plus adjacency list of p of I dot pushback I, because from pi I can go to I, right? Because p is the parent of I. So another, other than that, what I need to do, I need to have a count of the characters A to Z in the subtree for all the nodes, right? So let me take long subtree count for all the n nodes and for all the characters 26. So subtree of ij will denote the count of characters j in the subtree of node I. Okay, and what else I need? I need the total counts of each character. So let me take a total of 26, right? So for I equals to 0, I is less than 26, I plus plus, let me make total of I as 0. Okay, and let me take for I equals to 0, I is less than n, I plus plus. For j equals to 0, j is less than 26, j plus plus, subtree of ij equals to 0. Okay, so I have initialized all of them with 0. Now in total I have the total count of the characters. Okay, so total of I will represent the count of character I in the complete tree. So let us fill it first. So for I equals to 0, I is less than n, I plus plus, uh, total of C of I minus 97 plus plus. Okay, so this will give me the total count. Now the subtree count, that jth character is present how many time in the subtree of I, we will count it after calling a DFS, right? So let us call it. So let us call a DFS starting from 0th index, and we'll pass the adjacency list. We need to pass the subtree array, and we need to pass the string C, right? So let us call void DFS int I, and let us also pass the answer variable. Okay, answer is initialized to 0. Okay, so int I, then vector adjacency list, and uh, subtree. So long subtree of, it is a 2D matrix, right? Then I need long c, sorry, this is the string C, right? So string C, I'll also need the count of total characters. So total array I am also passing. This is the string C. I am passing the total number of characters also. So I'll pass total, and I'm passing answer variable also, right? So let's take long answer. I'll pass it as reference because that was declared in the main function, right? So now what I want to, first of all, I'll mark this as visited of I as true. Okay. Now if I'm considering the ith node as the center node in the triplet A, B, and C, then there are two cases, as I said. One where A is in its subtree and C is in the remaining part of the tree, right? and the other is that A and C both of are in its subtree, but they are in different branches, right? So what I can do is, after traversing from each branch, my total of ij will change, right? So what I can do is, so I can say, suppose I am here, right? So here total of, suppose I have traversed this branch, then total of 1 and 0 will represent count of character A in the subtree of, sorry, not total, subtree 1 0. This will represent count of character A in the subtree of index of node number 1. So after I have traversed this branch, this would be equal to 1. I have not yet traversed this branch. Now when I'll traverse this branch, I'll know that there is one A here, right? So suppose there were three A years, suppose I have A year also and A year also. So in this sub branch, I know that the count of A is 3. So each of these A can be can be paired up with this A. So from year to year I have one path, from year to year I have one path, and from year to year I have one path where this is acting as the middle element. So what I can do is, I'll, so basically to make a bit more clear, let me take, suppose here there are four branches, okay? So suppose after traversing this branch, I come to know that there are seven A's in this sub branch. Then after traversing this sub branch, I came to know that there are five A's in this sub branch. So can I say 7 into 35 number of triplets would be possible, where this would be the middle element, and I'll pick one A from here and one A from here. Then suppose there are three number of A's, three A's in this branch. Then can I say these three A's can be paired up with 7 plus 5, 12 A's. So 12 into 3. So there will be total how many? 36 paths, where this is one of the considered element, this is the middle element, and the one A is from this or from this. Similarly, here there are four A's. Then the total number of paths where this is the middle element, one of them A is from here and one of the A is from the remaining elements, is how much? 4 into 7 plus 5 plus 3, which would be how much? 12 and 3, 15. This would be 60. And at the end, we will multiply all of them by 2, because this path and this path are considered two different, right? So that is one case. So what I can do is, after I have traversed, after I have made a DFS on a branch, I'll have the total count. So for auto X in the adjacency list of I, call a DFS on X, pass the adjacency list, pass the subtree 2D array, pass the string C, and pass the total value. And what's the last? Pass the answer. So now I have calculated the count of each character in the branch which starts from X, right? So can I say, for, let me take int j. So for j equals to 0, j is less than 26, j plus plus, my answer would be equal to answer plus, pick the jth character from the subtree starting from x. So subtree of x and the jth character, and take jth character from another branch that would already be calculated in the subtree represented by I and j, and multiply it with 2, because there are two such paths. And now add the count of j from the subtree starting with x into I. So I can say subtree ij plus is equals to subtree xj, right? So the total count of j will increase in the subtree of I, because x is one of the branches of I, right? And after doing this, I can call on the another branch, right? Also, Now another possibility is that one of the element is in the subtree and another is in the remaining part of the tree. So I can say for j equals to 0, j is less than 26, j plus plus answer is equals to answer plus subtree of ij, that is the count of character j in the subtree of I multiplied by total count of character j minus the count of character j in the subtree represented by I. So one j character is in its subtree and another is in the remaining part of the tree. That will also form a simple path. Okay. So that's one thing, and at the end we will increment the count of these characters. So subtree of I and c of I minus 97 plus plus. Okay. So this is the answer one. So now basically also here we need to, I think, change a bit, like there might be a if statement, because we are adding this count afterwards. So I can say if c of I minus 97, that is the current node's character, is equals to j, then that should also not be counted because that's the middle character. So I'll do minus 1, else answer is equals to answer plus subtree of ij multiplied by total of j minus subtree of ij. Okay. And here we will not multiply it by 2. Why? Because so this case covers what? Suppose here I have a and a, here this is c and this is also c, right? Suppose this is a and I'm considering this as the middle element. Suppose this is d, then, or let us take original example only, this is a and this is c, then one of the characters is the child of this, so that is in the subtree of 1 0 would be what? 2, because it has two number of a's in its subtree, and the total number of a's is how much? Total of 0 is 3. From 3 if I subtract 2 I'll get 1, that is the a in the remaining part, right? So it would be this will be 2 into 3 minus 2. So I'll get two paths, that is from year to year and from year to year, right? But should we consider the reverse also? Because if this is considered as the center part, yes, then that will also be multiplied by 2, right? So this will be multiplied by 2 and this should also be multiplied by 2, and this should give us the answer. So let us return the answer. V was not declared. Okay, so we do not need to mark v of I as true because we are doing a DFS, but we in the adjacency list we added a path from parent to child only. So from child to parent there is no path, so we can directly traverse. So we have got 8. Let us submit it. So we have got segmentation error. That might be because we are declaring a 2D array of size n into 26. So let us make it public, then it might solve the problem. N was not declared, so n can be maximum. So we are getting segmentation error, right? Because we cannot declare the array of size this much, so we need to optimize it. uh, so if we think of optimizing it, then it would be, so did you, is the concept clear? How are we making triplets? For each node we are considering it to be the center node, and finding the remaining two elements of the triplet which can form the palindrome. Now the remaining two elements should have the same character. So there are two possibilities if we want the center node to be on the simple path from A to C. Okay, there are two possibilities. So we are, if we are considering this as the center node, one by one we will consider each and every node to be the center node in the triplet ABC which we are trying to find. Then uh, one possibility is the first node in the triplet ABC is here and the another is in the another branch, but both of them are in its subtree. Then also this will come in the simple path and they may form a palindrome. So this is A, this is D, this is A. And another is that one of the nodes is in its child, so is in its subtree. So suppose we have A here, and the other node which we are considering in the triplet is in the remaining part of the tree. Suppose it is here, and we are considering this as the center node. So this is also a simple path where this comes in the simple path from year to year, and both of them are same, so they also form a palindrome. So all such cases we are considering all the elements one by one as the center node, and then we are finding the different things. So if we look at the code, so what we have done is, in total I get the total count of the ith character, and in subtree of ij I get the count of the jth character in the subtree of ith node. Okay, and then we call the dfs at the end. After, while we are backtracking, we will increment the count of that character in the subtree. And what we will do, answer equals to answer plus subtree of xj into subtree of ij into 2 will basically count the number of triplets where the first node, that is a and c, are in the same subtree but in different branches. Then after we traverse a branch, so whenever we call dfs on a particular node x, we are traversing the branch starting from x, right? And then that branch is also the subtree of I. So we say subtree of ij plus is equals to subtree of xj, right? Because now we will go to the next branch. So if a particular node has, let's say, multiple branches, right? So first we will for this node, first we will increment the count of all these characters after the dfs. Then we will increment the count of all the characters after dfs. But before incrementing that, we can form the triplets starting with one of the nodes here and one of the nodes here. So first we will calculate that, then we will add it to the total. Then we will calculate ending with this node and starting from one of these nodes, and we will add it, and so on. So that is basically what we are doing here. And this basically is the case when one of the nodes is in the subtree and other is in the remaining part of the tree. But now we need to reduce the array size. We cannot take the subtree of size n into 26. So at each step, basically we need the one branch count and the total child count, right? So how can we get it? So one thing which I can do here is I can take long current of 26, which will basically make the count of the 26 characters in the current nodes subtree, right? Because that is basically what I want, right? So let's say current of I equals to 0, right? But then how will we calculate for the child? Hmm. So the approach and the concept part is right, but we cannot declare an array of this size, so we need to reduce it, right? So it is failing on some test case. Hmm. So if we take one array of let's say current, it will keep the count of the current array. And so can we do one thing? We can pass child. We can take one array child of 26 and one as current. Okay, so let us take long current of size 26. So current of I equals to 0. So for the first node we will pass. So let us remove this subtree part. We will not be declaring this array because that's taking too much space. We are getting segmentation error. So let us pass this current, and we will not pass this subtree, right? We will be not be passing subtree, and we will be passing current at the end. Okay, so let me take long current, right? So in that I'll store. Now in the I have declared here one as child. So here what I'll do is mm, so in the child node. uh, any ideas what we can do here? So we cannot take the array of size and star 26. That's the problem what we are getting. So I need two things. One, the count of the characters in one branch at a time, and the total count of characters in the current subtree, right? So if I pass child from which is declared here in the DFS called on one of its child, and increment the count of child, right? So child of C of I minus 97. No, this would be current. So for the child, we are passing current in the parameter, right? We are passing child. So we will increment it, and answer will be equal to answer plus not subtree of xj. It would be child of j. So how many j characters are there in the child multiplied by current of j. So how many j characters are there in the current node multiplied by 2, and current of j plus will be equal to child of j, right? And similarly here this would be current of j into total of j minus current of j minus 1 star 2, and this would be current of j multiplied by current of j, right? And here I am incrementing the count. So let us see if this works. uh, Invalid conversion from long int to long int. Okay, so what's the issue? Okay, so this current is an array, right? It's not an element. Oh wow, we have got absolutely wrong answer. Have I made current of I equals to 0? Okay, current of c of I, current of j plus is equals to child of j, current of j. Okay, child of j into current of j into 2. Here I have made current of I equals to 0, total of I equals to 0, and plus child of j into current of j plus is equals to child of j, right? Have we taken answer as 0? Okay, we have passed answer as value only. Let us print the answer. Let us print the answer at every step so we know where we are going wrong. On the first call only it is acha. Here it should not be I, here it should be j. Okay, so now we have 0, then 6, and oh, we got 24. It should be 8, right? Minus 26. So where we are going wrong? This is j j j j. This is we have placed the indexes correctly, I hope. And um, so let us print the answer after every I. So COUTI and answer. So for when I was considered as 0, if we consider 0 as the center index, the answer would be 0. If we consider 4 as the center index, the answer would be 2, which is not possible, because if we consider 4 as the center index, 4 cannot work as a center index, right? Uh, so for 4, current of j would be 0. So we are getting like fourth node, for zeroth node we are getting answer minus 26, right? How is that possible? So this is going negative somewhere or what? Total minus current of J. Total minus current of J and minus 1 if C of I minus 97 equals to J, that's okay. Else COUTI J. Mm, 30 and 421626 and 0 minus 26. So for 3 it should be 0, for 4 it can't be 2, right? So basically if we try to dry run on our example, then it is 0th node with value A, this is 1th node with value C, this is which node? I think the third number node. Yes. So this is the third number node with value A. This is the fourth number node with value A, and this is the second number node with value C. So first of all, when I call DFS on this, I have current array, and it is all initialized with 0. Then when I'll call a child array and I'll pass it to this, okay? But before I pass it to any of the child, I should make it 0, right? So before I pass it to any of them, for j equals to 0, j must be less than 26, j plus plus count of j must be equal to 0, not count of j but child of j. Then only I should pass to it, right? Because every branch is considered as a different child, right? So now we have got answer 8. When 3 is considered as 0th center index, we cannot form any pair. When 4 is considered as center index, we cannot form any pair. When 1 is considered as center node, uh, when this is considered as a center node, then we can get 6 things like 31a, sorry, 310 3 410014 and 314413, right? Then when 2 was considered, the still answer would be 6, and when 0 would be considered, the answer would become 8. Okay, now let's comment this out. Let's submit this, and then let's pass. Oh, it gave time limit exceeded. We are using too many for loops for this child, and okay. Okay, so I think the concept is same, but we are not able to implement it. I hope the concept is clear. So let's stop here. What I'll do is, if possible, I'll make a separate video solution on the third question of this weekly coding contest and upload it by Tuesday or Wednesday. Okay, in which I'll explain the concept also, and I'll also explain the solution code. So I'll try to make that. I'll talk with the management, and if possible, I'll upload a separate video on that, because here we are not able to code it efficiently. The concept is the same, like one after the another we can consider every element as the center element, but there might be a different approach where the coding part would be more optimized maybe. So first of all, it was giving us segmentation error, we removed that. Now it is giving us time limit exceeded, right? Maybe because on every node we are using 2 to 3 for loops of size 26, right? So that might be the case. Can we remove this for loop, like No, I don't think so. But I hope the concept was clear. So that's all for today. Let us end this live session here. I hope you understood the first and the second completely. For third, I was not able to code it, but I'll try and make a separate video, and in which I'll explain it in a much detailed manner and exactly how it will be coded. Okay. Thank you for joining, and sorry for the inconvenience because we also started late and I was also not able to code the third one completely. Yeah, thank you. Take care. Good night.